Dear First Prep, Assalamu alaikum wa rahmatullah wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Algebra Unit 2, Lesson 2. The lesson is called Probability. This is not a new lesson. You have studied the probability in the primary stage. Okay, what is the probability? Probability is a science that we are going to use if we have a new business, for example. We can use the probability to predict the business and the successful of the business in a new place. Okay, or also if we need to test the weather in place, or predict what is the time of the rain, for example, or how time it rain in this area. Also we use the probability, so it is a very important concept. Let's start the lesson. First, we are going to study the experimental probability. This is a new concept, okay? The experimental probability, or the probability we are going to use in the in actions or experiments. For example, if this swimmer, if we going to join a champion and we need to predict his time in the next champion, so we are going to make many exercises, and we are going to calculate his record in this exercises. And so we are going to collect how many times he practicing, and divided this number of times over the total time he did. So we are going to evaluate his time in the next champion. Okay, now another example. Now we have another example. Okay, if we tossed a piece of coin with double face 100 times, and the result of the appearance of a head or tail in each toss were recorded in a table. Okay, we know that the coin included two faces, head or tail. Okay, if we flipped this coin 100 times, okay, and we are going, this is an experiment, okay, and we are going to record this number of times in a table like this. Okay, the head was 53 times and the tail was 47 times, and the total number of times was 100. Okay, now if I need to evaluate the probability of appearance of a head, it's equal what? The head, the number of times equal 53, and the total times equal 100, so it is equal 53 over 100, or it is equal 0.53 like this. Or if I need to write it in the percentage form, so it will be like this, times 100, so it is equal 53%. Okay, now if I need to evaluate the probability of appearance of a tail, it is equal the number of times of tail, which is 47, over the total number, which is 100, so it is equal 47 over 100, or 0.47. This is in form of decimal. If I need to write it in form of percentage, so I'm going to multiply by 100, so it will be 47%. Okay, the definition of the experimental probability, it depends on performing an experiment. Then we record the results and use them to calculate the value of the probability of an event occurrence. It means as I did in this example, okay, I did the experiment 100 times and I recorded, okay, the number of tails and the number of head like this, and by using the rule, the probability, if I need, for example, the probability of head, it is head over total, and the probability of tail equal tail over total. So the experimental probability depend on using or making experiment. Okay, now let's study the theoretical probability. The theoretical probability. The theoretical, for example, in the previous example, we carried out the experiment of tossing a piece of coin, and we found that the probability of a head was 0.53. This is as I explained in the last example. Okay, and the probability of the appearance of tail equals 0.47. This was the experimental probability. What about the theoretical probability? The theoretical probability, I don't need to make experiment. Okay, I just evaluate the probability without making experiment. Okay, how come? For example, in this, if I need to evaluate the probability of appearance of a head, okay, in the coin, we have how many head? We have one head, okay, and we have how many face? We have two faces. So it is one head over two faces like this. It is equal 1 over 2. 1 over 2 equals 0.5 or 0.50. Also, if I need to evaluate the probability of appearance of tail, okay, so it is equal the number of tails, which is 1, over the total number of faces, which is 2. So it is 1 over 2. And 1 over 2 in the simplest form, or in the decimal form, equals 0.50. Finally, by comparing between the probability in the experiment and the probability theoretically, okay, we found it's very near to each other, 0.53, and here it's 0.50. And also the tail in the experiment 0.47, and here it's 0.50. So we find that evaluating the probability in experiment or theoretically very near to each other, but it's better to evaluate it by the experiment, okay, because it gives real values. Okay, now let's study the components of the probability. Okay, first we are going to study the random experiment. What is the random experiment? When we do any experiment without looking to the result directly, so it is called random experiment. Again, it is an experiment in which we can specify all its possible outcomes before carrying out, okay, but we can't determine certainly which of them will occur. Okay, what does it mean, Mr. Ahmed? It means when we flip the coin, okay, so I know that the appearance will be head or tail, okay, but I don't know exactly what will happen, okay. And also another example, if I flip the coin, if I flip the dice once, and all of us know that the dice included 6 faces from 1 to 6. So I know that all possible outcomes are 1, 2, 3, 4, 5, and 6. But I don't know exactly what face will appear. Okay, now we have a new concept called sample space. The sample space, it is a set included all possible outcomes. Again, it is set of all possible outcomes of a random experiment, and it is denoted by S. Okay, for example, When we toss a piece of coin once, then the sample space is what? When I flip the coin once, as I said, the appearance will be head or tail. Okay, so we are going to write the results inside a set, this set called sample space. So in this example, the sample space is the set of head or tail. Another example, when we roll the fair die once, observing the apparent number on the upper face. Okay, so we are going to write the results inside a set. The results are what? Are 1, 2, 3, 4, 5, and 6. So the sample space equal 1, 2, 3, 4, 5, and set inside the set. The set called S or sample space. Now we study the random experiment, the sample space. Of course, you don't need to study the definitions because the definitions, okay, doesn't include it inside the exam, but we need to understand what is the sample space, what is a random experiment. Okay, and also the theoretical probability and the experimental probability, okay, don't include it inside the exam. Okay, the exam don't ask you about the experimental or theoretical, but it's important to you to understand the difference between experimental probability, which depend on experiment, okay, and collect the data inside table, and the theoretical probability which we studied in this lesson. Okay, now we have to study a new concept called the event. What is the event? The event is a subset of a sample space. Okay, for example, if A, okay, is an event of appearance of an odd number when rolling a fair die once and observing the appearance on the upper face. Okay, this experiment, I said in the last example that the sample space equal set of 1, 2, 3, 4, 5, and 6. This is the sample space. The sample space included all outcomes from 1 to 6. But the event, he will ask you about a condition from this sample space. For example, in this example, he asked me about the odd numbers. Okay, the odd number, and he call the event A. He call it A. So A equal what? A equal the odd numbers here. The odd numbers are 1, 3, and 5. So A equal 1, 3, and 5. By looking carefully, A equal 1, 3, and 5, and 1, 3, and 5 subset from the sample space. So we said that the event is a subset of the sample space or a part of a sample space. Okay, another example. If we have another event B, and B represent the even number. Okay, the even number from here is 2, or 2, 4, and 6. So B equal 2, 4, and 6. 2, 4, and 6 are the even numbers from the sample space. Now we studied the sample space or all possible outcomes, and we studied the event and we said the event is a condition from the sample space. Now let's study how can we evaluate the probability. Now if I need to evaluate the probability of A, P of A equal the number of elements of the event A over the number of elements of the sample space. This is the rule of the probability. Number of elements of the event over the number of elements of the sample space, which means the total number. Okay, which is equal n of A. N means the number of elements of A, and n of S equal number of elements of the sample space. For example, if I need to evaluate the probability of the event A, A equal 1 included 1, 2, 3, 3 elements. Okay, and S, or the sample space, included 6 elements. So the probability of A equals 3 over 6. And 3 over 6 in the simplest form equal 1 over 2, okay, or 0.5, okay, in the form of decimal. And B also 1, 2, 3 elements over 6, which is equal 1 over 2. Now let's solve the next question. Example 1 with us. Here, as throwing a fair die and observing the upper face, complete the following. The probability of appearance of the number greater than 2. Okay, first S. S, or the sample space, equal 1, 2, 3, 4, 5, 6. Okay, and I'm going to call this event A. A equal set of number greater than 2, so it will be 3, 4, 5, and 6. So it will be, we have now 1, 2, 3, 4 over total number 6. 4 over 6 equal 2 over 3. Okay, now I'm going to call this event B. Here B is the appearance of number less than 3. So B equal 2 and 1. So it is equal 2 over 6, which is 1 over 3. Now this is, I'm going to call this C. Appearance of the number 4. So it is equal 4. Now this set included one element only. So it is 1 over 6. Okay, now 4, probability of appearance of the number 7. Now I'm going to call this event D. D here equal number 7. Number 7 is not included in the sample space, so D equal 5. And this is called impossible event. Again, this called impossible event, and this event equal 0 over 6. Why 0? Because the number of elements inside phi is 0 over 6 equal 0 finally. And this is the probability of the impossible event, remember. Okay, number 5, I'm going to call this one E. E is the appearance of number less than or equal to 6, which is 1, 2, 3, 4, 5, 6. Okay, probability of this event equals 6 over 6, which is 1, or equal 100%. 1 equal 100%. This one called certain or sure event. Again, called certain or sure event. Remember, this is the impossible event, and this is the sure event. Okay, the probability of appearance of a prime number. Okay, what is the prime numbers? The prime number, now I'm going to call this event F. The prime numbers are 2, 3, and 5. Again, 2, 3, and 5. The probability of this event included 1, 2, 3 over 6, which is 1 over 2. Here, this one called I, I'm going to call it I, the appearance of a prime and even number. Okay, now the prime are 2, 3, and 5. The even number between them is 2. So I equal set of the element 2. Okay, now this one included one element over 6. Now, number 8, the probability J equal number divisible by 5. Divisible by 5, which is table 5. So it is 5, 10, 15. But in the sample space, there is only 5 that divisible by 5. which is equal 1 over 6. 1 because we have one number only over 6 numbers. Okay, now let's study some remarks. First, the impossible event. The impossible event, you don't in the exam he don't ask you about the definition, but you have to understand. Okay, the impossible event, the event that has no chance for occurring. For example, in the last example, the event D was an impossible event because in D he asked me about number 7, and the number 7 wasn't included in the sample space or in the dice, so it was phi. So the impossible event equal phi, and its probability equal 0. The probability of the impossible event equal 0. He will ask you about the probability. Okay, now the certain or sure event. The certain or sure event, the event that hold all possible outcomes. For example, last time the event E was numbers less than 7, which was 1, 2, 3, 4, 5, 6. This event included all outcomes, so it is equal to S, and the probability of the sum of the certain event equal 1 or 100%. You have to keep this one 1 or 100%. It's very important, but you don't need to study the definition. Okay, now in general, any event, because the least event is 0 and the maximum event is 1 or 100%, so the probability of any event is greater than or equal 0 and smaller than or equal 1. So any event included between 0 and 1 or 100%. Okay, because 1 equal 100%. Also, the sum of all probabilities of all outcomes of random experiment equal 1. What does it mean, Mr. Ahmed? For example, if we have a class, mixed class, okay, in this class, the probability of boys equal 0.7 and the probability of girls equal 0.3. If we add 0.7 plus 0.3, it is equal 1. So the probability of the whole class equal 1. So the sum of all probabilities equal 1. Now complete also the remarks. The expected number of outcomes of an event equal the probability times the total number. Now this rule is very important, and I'm going to give you an example to explain what the meaning of what I need. Okay, in this example, if the number of students in a class is 30 students, okay, again, the number of students in the class is 30 students. Okay, and the probability that this student wear glasses is 0.1. Okay, again, the total number is 30 and the probability of wearing glasses equals 0.1. If he asks me the expected number of students who wear glasses, this is what I said in the rule. I'm going to do what? The probability times the total. Again, the probability times the total. So it will be 0.1 times 30. 0.1 times 30 equals 3 students. And also, I can add this magic triangle, and it is very important. Sorry for the bad drawing. Okay, here the probability, here the number, here the total. Okay, the probability equal what? Equal number over total. Okay, hide the probability, and it is number over total. If he asks me about the number equal probability times total. Again, if he asks me about the number of outcomes, equal probability times total. Okay, now let's solve the next question. Now example 2, a class included 40 students, 30 of them succeed in math, 24 succeed in science, 20 succeed in both. Student is chosen randomly. Find the probability that this student. Okay, first we need to represent these values in event to make it easy. Okay, in a Venn diagram, he asked me the probability of succeed in math. Okay, the probability of succeed in math. Okay, now I'm going to draw this one in the Venn diagram like this. First, I'm going to draw two ovals like this and rectangle about them. Okay, now I have three values: math, science, and total. Okay, this is the class. This is succeed in math, and this is succeed in science. Okay, now the succeeded in both is 20. Succeeded in math and science in the same time. Okay, now the succeeded in math is 30. Okay, we have 20 succeed in math and science. So the remainder of 30 equal 30 minus 20 is 10. If you need to check, 10 plus 20 equal 30. This is the number of math. Okay, now the succeeded in science is 24. So 24 minus 20 equals 4. Finally, we have students doesn't succeed in science or math. Okay, their number is what? Which is the rest of the class. Now we have 20 succeed in both, and 10 succeed in math only, and the 4 succeed in science only. Their number equal 10 plus 20 plus 4 equals 34. So the rest of the 40 equal 40 minus 34 is 6. Now the number of pupils who failed in math and science is 6. Okay, now the succeed in math equal 30 over the total. 30 over 40 equal, in the simplest form, 3 over 4. And succeed in science equal 24 over 40, which is equal, succeed in science 24 over 40 divided by 8 equals 3, divided by 8 equals 5. Okay, now failed in science. Okay, the succeeded in science 24. So 40 minus 24 equals 16. So it is 16 over 40, which is in the simplest form, divided by 8 equals 2, divided by 8 equals 5. So it is 2 over 5. Finally, failed in both math and science. Okay, failed in both math and science, this number, which is 6. So it is 6 over 40, which is equal, in the simplest form, 3 over 20. Okay, another example. A bag contains 5 red balls, 3 yellow, and 2 black. Find the probability that the drawn ball is yellow. First, the total. Equal 5 plus 3 plus 2 equals 10. So the probability of the chosen ball is yellow. It is equal 3 over 10. Okay, red, yellow or red. Yellow equal 3 and the red equal 5. So 3 plus 5, 8. So it is 8 over 10, which is equal 4 over 5. Finally, the probability the drawn ball is not yellow. So I'm going to cancel 3. The rest is 5 and 2. Red and black, they are 7 over 10. This is 7, okay? 7 over 10. The next example. Okay, a card is chosen randomly from a cards numbered from 1 to 10. We have 10 cards. Okay, what is the probability that the chosen card is odd number? Okay, the odd numbers are 1, 3, 5, 7, and 9. Okay, they are 5 out of 10. Equals 1 over 2. And an odd number greater than 3. Odd numbers 1, 3, 5, 7, and 9. Okay, greater than 3, it's 5, 7, and 9. Again, 5, 7, and 9, which is equal 3 over 10. Okay, prime numbers are 2, 3, 5, 7, okay, 2, 3, 5, and 7. 1, 2, 3, 4, so it is 4 over 10, or 2 over 5 in the simplest form. Two players play a football in a football team during training. One of them shoot 21 penalties, kick and scored 18 goals, and the other shoot 32 penalty kicks, and he scored 25 goals. Which of them should you choose to shoot a penalty kick and why? Now this is represent a experimental probability. Why? Because now we did the experiment 32 times and he scored 18 goals. Sorry, 21 times and he scored 18. And the other one shoot 32 and he scored 25. Okay, now to choose which one is better, so we are going to evaluate the probability of each of them. Probability of the first equal what? Equal he shoot 21 and he scored 18, so it is equal 18 over 21, the number of scored goals over the total number, which is equal, in the simplest form, divided by 3 equals 6, divided by 3 equals 7. But it's better to change into percentage. So I'm going to multiply 6 over 7 times 100. Again, 6 over 7 times 100 equals 86%, approximately. Okay, now the probability of the second equal, the second one shoot 32 and he got 25 goals, so its probability equal the number of goals over the total number, which is 32, so it is equal here 25 over 32, this is the simplest form, times 100, it is equal 78%. Which one is better? So the first one, because his probability is greater than the second. Okay, the first one is better than the second because it is 86 and the second is 78. So this is the needed of the experiment of the experimental probability. Okay, he gives or it gives accurate data. Okay, now example 7. No, example 6, sorry. Which of the following probabilities of occurrence of an event? Okay, the probability between 0 and 1 or 100%. Okay, now 1.2 is greater than 1, negative 0.4 less than 0, 315 greater than 100%, 75 between 0 and 100, so this one. The letter is selected from the name Zamalek. The probability of selecting letter A. Okay, now we have how many letter A? 1, 2, so it is 2 over 1, 2, 3, 4, 5, 6, 7 over 7. 5, a bag has 5 red balls, 3 white. Okay, so the total is 8. The total is 8. Okay, if the balls are similar and the person drawn a ball randomly, then the probability of drawn ball is white. Drawn ball is white. Okay, here we have 3 white over 8. 3 over 8. A basket contains cards numbered from 1 to 20. A card is drawn randomly. What is the probability that the number written is divisible by 6? Okay, divisibility by 6, okay, it is 6 over 6 equal 1, 12, sorry, 12 and 18, because 6 over 6 equal 1, 12 over 6 equal 2, 18 over 6 equal 3. Okay, now this is the number that's divisible by 6. They are 3 out of 20 cards, so it is 3 over 20. Now example 7. Complete the following. The probability of occurring impossible event equal 0, and the probability of occurring certain event equal 1. If a coin flipped once, the probability of appearance of a head, it's equal 1 over 2, because we have one head over 2 faces. If the probability of occurring event is 5 over 8, then the probability of that event doesn't occur. Oh, we took before that the total probability equal 1. Total equal 1. So the occurring of this event 5 over 8, so doesn't occur this event is 1 minus 5 over 8, which is 3 over 8. The probability of a person get infected in a city whose number of inhabitants is 20 or 200,000, okay, with disease is 0.003, then the expected number of infected person with disease is in this city equal. We studied before that the number equal probability times total. Of course, you remember this rule. Okay, so the number equals 0.003 times 20,000 or 200,000, which is equal 600 persons. Okay, the next question. A bag contains a number of similar balls, 5 of them are white and the rest are red. The probability of drawing red is 2 over 3. Find the total number. Okay, to find the total number I have two different ways. I can use the magic triangle, okay, but I think it's better in this example to use the ratio, and it's allowed to you to use the ratio. Okay, by using the ratio like this, I'm going to write, I have now white and red. Okay, we have white and red. So I'm going to write white to red to total or sum. Okay, the probability of red is 2 over 3. So the red is 2 and the sum is 3. Why the sum? Because the probability equal red over total or red over sum. So red equal 2, sum equal 3. Now to find the white, okay, so I'm going to subtract 3 minus 2 equal 1. Okay, now the number of balls of the white balls is 5. So I'm going to write 5 under 1 under the white. Okay, now I need the sum. So I'm going to make a cross multiplication. 3 times 5 over 1. So the sum equal 3 times 5 over 1 equals 15 balls. This is the first way. I can solve this one by another way. How come? Now we have the probability of red equal 2 over 3. So I'm going to find the probability of white equal 1 minus 2 over 3 equal 1 over 3. This is the probability of white. Remember with me the magic triangle. We have here probability, number, total. The total equal number over probability. Again, total equal number over probability. So the total equal number, which is 5, number divided probability. So equal 5 divided by 1 over 3. 5 divided 1 over 3 equals 15. The two answers are correct, or the two ways are correct. It's up to you. Okay, this is the end of the lesson. I hope it was helpful for you. See you inshallah in the next video. Assalamu alaikum wa rahmatullah wa barakatuh. Mr. Ahmed Mahmoud was with you.